So, because radicals can all be rewritten as what? Yes, good job, Justin. As exponents, then we need to talk about the exponential side of it, and then we'll talk about the radical side of it. So the first thing we'll do is we'll do rational exponent. Now, we've kind of done this a little bit. What is a rational exponent?
A fraction exponent.
It's a fraction exponent, okay? So, my question to you is, if I have a fraction exponent, let's say 2/3. Let's say I have something that looks like this. How do I solve that for x? In other words, what gets rid of that exponent? So I see Ayana back there making signs with her finger about roots and things. And you're not wrong, but I want you to think very carefully about this, about what, whenever we think about opposite operations and inverse operations to cancel things out, we think about what's going to make it go away.
Oh, multiply by 3
You're exactly right. You're exactly right. If you raise a power to a power, then you multiply, right?
Yes.
So if you multiply reciprocals, they cancel out and leave you with 1, right? So to get rid of a rational exponent, come on, pen. We raise it to the reciprocal. Now, what? What's 48 over 2?
16 over 1 times 3 halves.
Oh, no.
Or you want us to raise it?
Now, look, you got to raise it, right? Because when you raise, that cancels the exponents out. So these two are going to multiply to each other. But if I raise it to that power here, then I also have to raise it to that power here. So I'm not multiplying it on the right side. I'm raising it to that exponent. So it's gone on the left. Now I have 16 to the 3 halves. So think about that. 16 to the 3 halves. If I change the form, which is what we did at the beginning of this chapter, it becomes what? Square root. What is the square root of 16?
4.
What is 4 to the 3rd power?
Wait, what do you do? Oh, that's not that hard. Is this all we're doing?
Change that to the square root.
One of 3 scenarios.
I'll probably remember 2.
Okay. What if it doesn't work out exactly right? That is okay. Use your calculator and you'll round off to a decimal. Okay. I can put 16 to the 3 halves in my calculator. Does everybody know how to do that?
Wait, so question. Wait.
I'm coming back to it. I'm listening, Evan.
Oh, alright, so basically all you're trying to do is get rid of like the exponents.
I'm trying to solve for x.
Okay.
So here, if I did 16 raised to the, you have to put it in parentheses. 3 divided by 2. Does that make sense?
That cuts out a lot of steps.
Well, but remember there's a section on your test that's going to say solve without a calculator. So I'm looking for the steps. Or evaluate without a calculator. So the steps are what I'm looking for.
Will they work out neatly?
Yes, if I say without a calculator, they will work out nice and neat. All right, let's do another example that's a little more involved than just that one.
Is this test going to be on the computer again?
What? No.
Test? Okay.
No.
Yeah. I just plug everything into my calculator and get it that way.
That was highest grade I've made on a test so far.
I would not be doing y'all justice if I gave you all computer tests that were multiple choice.
Is this still
Okay, I'm still solving, yep, because the exponent's rational. All right, so remember when I solve for x and I only see x one time in the problem, I'm going sad map, right?
Yes.
Tell me, what do I do first? Add 1. Now what?
Yes.
So, exactly. So this is 3/4. I want to get rid of it because parentheses are my last thing. So to get rid of it, I'm going to raise it to 4/3. If I do it to the left side, I also must do it to the right side. So I got x plus 2 equals 16.
Why?
The third root of 8 is 2, and 2 to the fourth power is 16.
Oh, so you're subtracting that, right?
Yes, Evan, yes. So now I would just subtract 2. Yes, ma'am. Yeah, no, you can put it on your calculator if you want to. But if you have 8 to the 4/3, that means you're looking at the third root of 8 to the fourth power, which is 2 to the fourth power, which is 16. Yep. Tell me.
Logarithm.
Part 2 that I want to show you. Part 2 that I want to show you is with a radical, and I want to show you the scenario with one radical. Okay. Now, before I show you radicals, tell me this. If you have something like the square root of x equals 5, how do you solve that? Square. So what I'm getting at is, what's the opposite of a square root? An exponent of 2. What would be the opposite of a cubed root then? A cube. Those cancel, right, Evan, who was talking while I am?
I was just trying to say.
Evan, what's the opposite operation of a fourth root?
Fourth root is. Wait, write it out. Fourth power? I don't know.
Yes, that's right. All right.
Can you say that real quick?
Yes. Tell me what.
Make it by itself.
Make it by itself. So isolate that one radical. Make it by itself, in the words of Justin. So in other words, if I have, let's say, should we start hard? Should we start easy? Let's start easy. 2 times the cubed root of x plus 1 equals
That's not easy.
8.
You put the third power, cancel it out.
Isolate the radical first. You see that there's one radical.
Do you develop?
You get, yes, you divide by 2. You can't have anything except the radical and what's under it. That's it. Nothing else. Well, you got to get rid of the 2 in front first. Because before you can get rid of a radical, you must only have the radical on the side. The radical and what's under it, okay? So whenever I divide this by 2, I get the cubed root of x plus 1 equals 4, right?
Minus 1.
Not yet, because after the radical is by itself,
Now you do the third power.
Wait. No, I'm saying we don't say it.
once the radical is isolated and by itself, then we must eliminate the radical. Well, oh my gosh, how do you eliminate a radical like that? Do it to the third root, the third power. So I do it to the third and to the third. This is gone on the left. So I get x plus 1 equals 64. And now you should be able to solve it, yes? Now, I'm sure some of you are looking at this problem and going, Miss McGee, that's elementary. We know how to do that. Psh.
Yeah, that's not that hard.
It's really not that hard, right?
You're just thinking in your head like, nothing big.
Miss McGee, I would agree with you except that you're smiling.
You'll see
That
that.
makes me suspicious.
Yeah, she's driving away. She's getting ready to go. Is this the second part?
Okay, there's 3 parts I've done. This is the second part. All right.
Is this part of the second one? This part of
Yes.
We're all
this is
under
part
one
of
radical. It's all the same thing. Just doing different ways.
10x plus 9. 10x plus 9. 10x plus 9. Here we go.
I think I'm about to drop down to 60.
Okay. Yeah, I need to get the X. You did this. Oh, you got squared.
So the directions only say solve for x. Okay, so Olivia says we got to square it. So I see one radical. It's already isolated, right? It's already all by itself. Yes, Justin, it's already gotten by itself, or whatever you said. All right, so yes, Olivia, I'm going to raise both sides to the second power because I need to get rid of, the second thing I do is eliminate the radical. My question is, on the left side, it becomes 10x plus 9. Easy peasy, right? We know that. How about the right, what?
Why did you square both things in the time?
I do, I haven't done it yet.
Miss McGee, you talk and write faster than I can comprehend what you're doing.
Well, if my pen works. That works now. Yes, yes, you're both right. Sarah asked why it was just going to the 3. It was actually going to the whole side. I have to do the whole side, so I have to be careful with that. Can I distribute, Cullen, can I distribute that exponent?
She's distracting me.
Yes.
That was not the answer to my question. Can I distribute that exponent?
You distribute and it becomes x squared plus 3 or x squared plus 9.
Yeah, but then you're gonna have x squared plus 9.
All right, everybody listen carefully to my question. Can you distribute the exponent inside the parentheses there?
Yes.
No. Is the answer no? Is that why you keep asking?
Yes, the answer is no. That's why I keep waiting. I keep asking it.
No, I was right.
So it'd be 2x plus 3.
Remember, yes, it is a FOIL problem. Good job. Remember, the only time an exponent distributes inside of parentheses is when you are doing what? Multiplying or dividing. That's exponent properties. When it is adding or subtracting inside there, woo, we got to FOIL. Okay, you have to remember that when we get to rational expressions next chapter. That's crucial. Okay. All right, so this is a FOIL problem. So the right side becomes x squared plus 6x plus 9, yes?
Sure.
Wait. Just a minute.
Do I need to FOIL it out for you?
Yeah. No. 6x. Oh, we're using that. Never mind. I got it. Oh.
So now you just do it. Combine.
And do it. Just do it. All right. Is everyone with me?
Yes.
So now, right now we're in chapter 3, yes?
Yes.
Rewind back to chapter, do you have a question, Ayana? Okay. Rewind back to chapter 1 because suddenly I have a what? It starts with a Q? Quadratic. To solve, which opens up a whole world of different ways I can solve, but I know the first thing before I solve any quadratic is to make it equal 0.
Cancel out your 9s.
Get rid of that.
Minus 6x.
Do we have to do all that? Wait, why would you do negative?
So it's x squared minus 4.
It must equal 0. I have 0 equals x squared. Whoa, Nelly.
Whoa.
X squared minus 4x, and then the 9s are gone. This is an easy one. However, if I got here and it was not this easy, how might I solve it? Quadratic formula always works. It's a little messy sometimes. What else can we do? Factor and solve. What else can we do?
Can you do like the
Graph and find the x-intercepts. That's not a bad answer. What else? That's a little long. It's not that you can, but what you're doing something when you do that. What are you doing when you do the synthetic division and all that?
I don't know.
Starts with an F. Factor and solve. Did we say that already?
We already said that.
Oh, we did say that. Complete the square. That's what we forgot. Complete the square. Okay? So remember, no, I'm just telling you, you have to be able to recall that chapter 1 information and pull it back up as we start solving because quadratics are going to start popping up more and more frequently. Okay? All right.
Wait, are you done?
So I'm not done because I haven't found. I feel like I'm getting louder and louder to talk over you guys. I haven't found the value of x yet. So Sarah said factor out an x, and she's absolutely right because the first step in factoring is to find my GCF. I have a GCF. That GCF happens to be x. I have two things multiplied together to give me 0. What do I know if I have two things that multiply together to give me 0? I set each one to 0. One or both of them must be 0. There is one solution. There is another solution.
I don't understand.
All right, so I've got two things that multiply together to give me 0. The only way to get 0 when you multiply two numbers together is if one or both of them is 0. So to find the solution, I set both to 0. Record. All right, last scenario, scenario 3, is 2 radicals. And under 2 radicals, there are going to be 2 subcategories, okay? The first one is I only have 2 radicals and nothing else, okay? So in other words, maybe I have the square root of 2x plus 3 equals the square root of 5x minus 7. Okay. You're exactly right. So the key with 2 radicals is that you get one on each, and this is true whether it's this scenario or the next one that I show you. But you have to get the radicals separated. You gotta keep them separated. You have never heard that song before?
I haven't heard any of the songs.
Okay. Oh my goodness. Okay.
I've recognized all the songs that you play out loud except for that.
You don't know that one?
Wait, do it again.
Nope.
Okay. It wasn't really my type of music, but I know the song. Okay. No.
She said that, no.
All right. All right, so in this case, because that's the only thing there is, there's nothing outside of the radicals, it's an easy solve for us. Several of you have already said, well, if we just raise it to the second power, they go away, and you're absolutely right. This is easy peasy solve. Now, you know it shall not be this easy all the time, right? Okay, I can get the x's together. You will have several like this. It looks a lot worse than it is, and I'm going to add this 7 also. I'm going to do 2 steps at one time. I hope I don't confuse anyone.
What?
Really? I just did it. I did both at the same time.
Oh, okay.
I moved the 2x and I added the 7 all at the same
Are you
time.
just gonna leave
I just
it?
did 2 steps in one. 10 over 3,
I'm
yeah.
just asking how you can square.
Well, whatever you do to one side, you have to do to the other. So I squared the left, so
Well, if
that
they're
made me.
squaring both, of them, it doesn't change anything. Then you're just getting rid of this.
That's what I want to do because I want to solve for x.
You get minus 2x plus 7.
I subtracted 2x to get rid of that.
And then she.
I added the 7 to get rid of that. Yeah, do a step at a time.
Yeah.
But how can you just square it without it changing? Like,
I actually
you
like
love
this lesson.
seeing the confusion on their faces.
All right. So the first thing I need to do as I look at this equation is I need to determine, guys, what scenario I'm in. Scenario 1, scenario 2, or scenario 3. Scenario 3, 2 radicals.
Oh, buddy.
So I get them separated. Oh, wait, they're already separated, right? Separated meaning one on either side of the equal sign. So my only option now is to try and eliminate the radical.
Square everything.
Square everything. You're exactly right. Now, y'all, hold on to your panties.
I don't like that word.
I really don't like that word.
Okay. Evan, look at the right. And that's gone, yes? However, look at the left.
It's not gone.
Uh-oh.
You have to boil it.
It's a FOIL problem. Now, y'all stay with me because it's a FOIL with a radical. So I am going to show you this step by step, and I'm going to do it very slowly.
Your slow is like 2 times the speed I can come.
All right, watch what happens.
Slow, aka speed.
All right, I need everybody with me. This is tough, and you have one like this on your test. Okay?
Why would you do that to us?
Because you have at least one of these on your test. You have at least one of each scenario. All right. To solve this, I'm going to FOIL the left. The key here is looking at the root x plus 6 as a piece on its own. Okay? So I'm going to take this and I'm going to multiply it. What is the square root of x plus 6 times the square root of x plus 6? Correct. The square root of x plus 6 times the square root of x plus 6 is the same thing as the square root of x plus 6 squared, which cancels, so it leaves us with.
Then why couldn't I have just
But then you have
squared it
to
and crossed
distribute
it out?
it too.
Because you have that too.
I would just say
All right. Oh,
Okay, so
okay.
I know, but then you minus
2 times the square.
Minus 2 times the square root of x plus 6.
Do that again, right? 'Cause it's the same on the inside.
Okay, I've foiled the first term. Now move on to the negative 2. Negative 2 times the square root of x plus 6 plus 4. Should be downhill from here for you. The hardest part of this is foiling, but they do not. But they are like terms or like radicals. So, I got x, and let me combine these first. 6 and 4 give me what? 10. 2, negative 2 and negative 2 are the coefficients. Together would give me all right, so stop here a second. I have an equation at the moment that has one radical in it. Isolate the radical. Now I'm back to scenario 2.
Subtract the x plus 10 and then you go
Subtract the 10. I'm going to do this in 2 steps here so you see, because I confused some of you before. I've got x minus 4 root x plus 6 equals x minus 12. Okay.
Then you can slash the x's after
You're exactly right.
and divide by 8.
The x's do when you subtract them. Ah! Oh no. Thing. But I don't know what's wrong with it. So yes, you move the x.
Maybe I'm sending too close, please.
Why? Because you're getting it?
No, I mean like it's messing up. So like,
Oh.
probably just.
I did. Is the radical now isolated?
No, you gotta divide by negative 4.
Look at you, Evan. I'm impressed. No, Evan's paying attention. Yeah. We've always known Evan was smart. He just doesn't always pay attention
I
like
just
he
like
should.
interacting more. Like, I don't take interacting. The last notes I've read is the first slide. I like to interact. That's how I am in chemistry.
How do I solve this now? Square both sides.
I went ahead of you with all that.
Evan, yeah, that's okay. I will forewarn you though. Make sure you go back and write them down. Watch the videos and write them down. I know, but I'm saying, like, because when your cumulative test comes around, or even when the chapter test comes around, whoo, it makes sense in class, and then, all right, yes or no, that's 3 scenarios, 3 different things.
Wait.